Hello, and welcome to the K8ssandra scaling demo. In this demo, we're going to cover how a K8ssandra cluster supports scaling up and down resources to meet your needs. In this scenario, our application is supporting a retail shopping cart experience. We're approaching the holiday season and want to scale up our cluster to provide for greater availability and higher performance during this critical traffic time. To get started, let's review our environment. Here, we already have a K8ssandra cluster up and running. It's composed of 3 Apache Cassandra nodes. Each node is running on a separate cloud-managed Kubernetes worker, one node per AZ in a regional deployment. To meet our capacity goals during this peak season, we want to double the size of our cluster from 3 to 6. Let's take a look at our current deployment's Helm chart values and see what the shape of this looks like. So here we can see our running cluster. If we go here into our YAML file, we can see the size is 3. We're spread across our 3 racks, and these are the AZs that they align to. So we want to make this 6 nodes. There we go. We're going to save, switch over here, go to our terminal and run the Helm upgrade command. So the Helm upgrade command handles templating out all of our Kubernetes resources. It'll then push those resources into the Kubernetes cluster via the API. So while this is running, we can go over to our custom resources. The definitions, look at our CAS DCs, look at DC1, and let's see if this has already been updated. Since we haven't had the text update here, it's not quite yet, but we can go in, close the metadata and status fields, go into the spec, skip over to the config, manage API, pod template spec, there we go, racks, and then finally size is 6. So we've received the update here, and we can see immediately that the CAS operator has taken the updates from our CAS DC and translated those into changes within the Kubernetes API. So it said, hey, stateful sets, you need to have 2 nodes per stateful set instead of 1. And then the stateful set controller within Kubernetes said, okay, well, we need to turn those into pods. It's created the pods. We can see all these pods have already had their init containers run, and they've actually started the Cassandra container. Now, inside of that Cassandra container, we have a management API, which actually handles the bootstrapping process and forking off the Cassandra process. So here we can actually see this one has already received that start command and returned a 201. So if we go over here to the server system logger, we can see it's gossiping with the existing nodes in the cluster. It'll wait a few seconds between rounds, make sure everything looks good. It'll figure out what part of the cluster it's going to take ownership of, start to stream the replica from existing nodes, and then start accepting client connections. So we'll give this just a moment. Here we can see these are the new token ranges that it's taking ownership of. It's sent that out to the cluster. It's waiting for a little while just to let that settle, let the cluster say, okay, that's yours, fine. And then we will start accepting connections from clients. It's already gossiping with all the other nodes in the cluster. And we should see it turn green here in just a second. Yep, streaming data. Finish joining the ring. You can see connections from the other nodes here in the cluster. Connection timeout, that's not the end of the world. Keep going. And there we go. It's now finished joining the cluster. So we're just going to let this run for a minute, let all 6 nodes come up, and then we'll move on to the next section. The second node has already started the bootstrap process. The second node is complete, moving on to the third. And it's worth noting that it takes about 2 minutes per node for this bootstrap process to complete. All right, startup is complete, and all of our nodes are green. So with the cluster in this state, we're ready for our peak load and can safely support our customers and application needs. After peak season, though, we want to control our cloud spending. So from here, we want to scale our cluster back down to 3 nodes without any data loss or manual intervention. So just like before, we're going to take a look at our values.yaml, change this from 6 to 3, save the file, go back over here into our Helm, or run our Helm upgrade command. We can see Kubernetes had to restart this pod. Again, it's automatically reconciling. We haven't had to do anything. Helm is going to template out all the config files, Kubernetes resources. So our CAS DC will be updated from 6 down to 3. There's our racks, there's our resources. So the size is still 6, but we'll see it switch out here momentarily. Oh, and looks like this just updated. Oh, no, the size is still 6, but we've updated here. So if we go one more time, status spec, close the config, close the pod template spec, look at racks, resources, size is now 3. That's what we expect it to be. We go back up here to the pod view. We can see it's already going through the process. Well, that node is getting restarted. So what we'll start to see happen is individual pods will be terminated, but we're going to do that in the following best practices. So we'll actually drain the node of client connections, inform the rest of the cluster that this node is leaving. Other replicas will take ownership, start streaming the pieces of data that they're responsible for now that one of these nodes is leaving, and move forward. So here we can see this node is already failing its status checks, which is indicating that it's terminating, and we will see it go away. So our third rack is already down to one node. We're going to see probably the second rack kick off next. And if we look at the management API logs, we can probably see, the readiness and the liveness checks, but you'll see the actual call command to terminate this node. So we're going to wait a moment and let this finish its scale down operation. Pod ID 1 in rack 2 is terminating right now. And in just a moment, we will see pod ID 1 and rack 1 follow that same path. In this demo, we've covered scaling a K8ssandra cluster up and down to meet your deployment requirements. Teams can integrate this workflow with GitOps for stable, peer-reviewed deployment of operations to Cassandra workloads. The process of interacting with each individual node is handled through automation, and that frees your team to focus on things that are a bit more interesting.
So thank you for attending this demo. Be sure to check out all of our other demos and join us at K8ssandra.io.